So take a look at these three graphs. Between the three of them, can you tell which object is moving the fastest, which one is speeding up, which one's slowing down? If you're not sure, that's what I'm going to teach you in this lesson. Today, we're talking all about kinematics graphs, specifically position versus time, and how to interpret different features of this graph, including what's on our x and y axes and what the slope can tell you about the motion of an object. So first off, we have a position versus time graph. So that means that position is on the y-axis, so your y coordinates indicate the position, and on your x-axis you have time. So usually that's time in seconds and position in meters, but one of the first things that you always want to do when you have a graph is check what is on your x and y axes and what units that they're in, because you're going to see multiple different graphs often together in the kinematics unit. So you want to know, are we dealing with position versus time, velocity versus time, or maybe even acceleration versus time? So check in with what's on your axes. And also another important feature of our graph here that we see is the slope. So slope on any graph is an indication of the rate of change in something. So on a position versus time graph, we're looking at the rate of change in position. That's what our slope is telling us. And that is pretty much the exact definition of what velocity is. So when we look at the slope of our position versus time graph, that is going to give us velocity. Now we can find an average velocity by picking just 2 points off our graph and finding a slope of a line that would go through them. Or we can think more about instantaneous velocity as what is the slope of a tangent line at a particular moment in time. But it's important to remember in general that the slope on a position versus time graph is the velocity. And here's an equation that we can match up with that idea. So slope is rise over run. Here we see rise as change in position, run as change in time. So that is going to give us an average velocity. And so of course, time isn't really going to be positive or negative. So we only have like positive numbers on our x-axis, but position can be positive or negative. And position being positive or negative, so being above or below the x-axis, only tells you where you are in relation to some origin or 0 meter mark. So whether the position is positive or negative does not tell you anything about the actual direction that the object is moving in. And direction of motion, aka the direction of displacement or velocity, that can be positive or negative. But to find the direction of motion and to find the sign of velocity, we have to again look at our slope and see, is our slope positive or is the slope negative? That's what's really going to tell you the direction of motion, is the sign of the slope. Another thing that the slope is going to tell you is if we look at the shape of the slope, whether we have a constant slope, so more like a straight line situation, or we have an increasing slope or a decreasing slope, those different shapes to our slope are going to indicate whether the object is moving at a constant velocity or if it's speeding up or slowing down. So a constant slope, positive or negative, means that the object is moving with a constant velocity. A slope that's getting steeper over time, we would call it like an increasing slope, indicates that you have an object that's speeding up. And if you have a decreasing slope or a line that's kind of flattening out over time, that indicates decreasing velocity or an object that's slowing down. So let's take a look here at 3 examples of graphs that represent constant velocity. So here, this graph shows you that you have constant velocity because again, well, they all show this. They show constant slopes, so like straight lines. One of them, so this first one here, is a positive constant slope. So it shows positive constant velocity. Another piece of information that we can get from this graph is the object's starting position And that comes from the y-intercept of the graph. So with this y-intercept being 0, that indicates that the object's initial position is 0, and then it heads off in the positive direction. In our second graph, here we have a positive value, so some positive value for the initial position, but our slope is negative and constant, so we have an object that's traveling at a constant velocity in the negative direction. So if we had numbers here, we might see something like a slope of negative 4 meters per second to indicate the magnitude and direction of velocity via the slope. In our last graph, we have this just straight line, but the slope is 0. So what does that tell us? We have the same position, no change in position over time. So this is an object that is just simply hanging out at rest. Now let's take a look at some graphs that show an object that's speeding up. So for, again, showing speeding up, we should see that the slope of the graph is getting steeper over time. So we see a curve to graphs with changing velocity. In our first graph, we have an increasing slope with an upward trajectory. So we have a positive and increasing slope. So positive increasing velocity. And you may remember from previous videos, or I'll link this one here, that talks in depth about how the signs of velocity and acceleration work for objects speeding up or slowing down or constant speed. But if you don't remember, I'll remind you, the rule is that if you have velocity and acceleration that have the same sign, the object is speeding up. If velocity and acceleration have opposite signs, that's an object that's slowing down. So for this graph, we know that the velocity is positive because we have a positive slope. And if we're trying to determine the sign of acceleration for this case, we can say, okay, this is a graph of something that's speeding up, so velocity acceleration must have the same sign. Velocity is positive, acceleration is positive. Now, if we look at the other graph, we see an object that's speeding up, but in the negative direction. So slope is getting steeper, but it has that downward trajectory. So we have a negative velocity, but it's speeding up, so we have negative velocity and negative acceleration. Next, we'll take a look at objects that are slowing down and what their position versus time graphs look like. So for the first one, we see positive decreasing velocity. So positive slope, but that slope is leveling off. So again, let's think about signs of velocity and acceleration. So positive velocity, but it's slowing down. Velocity and acceleration have opposite signs. Positive velocity, negative acceleration for this guy. For our other graph, we have an object moving in the negative direction and slowing down. So negative velocity, but positive acceleration. Remember, positive acceleration does not necessarily mean speeding up. Negative acceleration does not necessarily mean slowing down. We have to compare with the sign of velocity to figure out what's going on. So here we see a graph that looks like an upside down parabola. So we'll split this graph in half and look at the left side versus the right side because we have a change in like the trend of our slope. And that happens like right after the midpoint here, our maximum height. So this graph would be consistent with an object that's initially moving upward and then comes back down. So if you throw something in the air and then comes back down, this is a graph, position versus time graph, that would match that scenario. So on the left-hand side of our graph, we have a positive but decreasing slope. So we have positive decreasing velocity, which again is consistent with an object thrown upward in the air. It's moving up in the positive y direction, but it's slowing down. So the left-hand side is described by positive velocity and negative acceleration. Then we reach this maximum height, but there's something interesting going on here. You have this instantaneous slope of 0 right at the top. So if we're drawing tangent lines, they're positive, getting less steep, less steep, less steep. It hits 0 at the top, and as we go over to the right-hand side, now we have a slope that is negative, but getting steeper and steeper. So we have a velocity that is negative and increasing, so speeding up. So negative velocity, negative acceleration for this position versus time graph. So at first it's moving upward, slowing down, then it's moving downward and speeding up. So to do a quick summary here, when we're looking at position versus time graphs, we're reading the slope as velocity. We can calculate an average velocity using 2 points on our graph and calculating the slope, or we can simply just like describe what's going on, speeding up, slowing down, constant speed, and a direction of motion by just describing the slope as increasing, decreasing, or constant, and just seeing whether it's positive or negative. So next time we're going to take a look at velocity versus time graphs. So make sure you check that out if you're in the kinematics unit right now.